Hey everybody, thank you for coming to my talk on Project Panama. What's it all about? So this is a little bit about me. I'm a developer advocate for Azul Systems. We create Java runtimes or high-performance Java runtimes for companies to help reduce infrastructure costs. So more about me later, but I used to be a book author and related to Java FX, so I'm a big fan of that. So what's the state of Java and Java native access? Real quick, a show of hands. Anyone know what JNI is? Excellent. Okay, and those that don't, which is cool, this is a good talk for you also. But for those that know about JNI, so really quick, the state of JNI. I'm sure everyone has heard of, those that have not heard of it, have you ever heard of Minecraft? It's like really famous, right? So this guy is written in Java. Wow. So you're probably wondering, well, how does it achieve all these high frame rates? And, how does it perform so quickly? And, shaders and 3D graphics and floating point math. It actually does it off, it doesn't do it in the CPU, it doesn't in the GPU, which is actually, off of, it's natively on the GPU. So it can do a lot of concurrent calculations, it's doing pixel shaders and a lot of vector math in concurrency. But what it uses is a library called LWJGL, Lightweight Java Gaming Library, which the underlying implementation is written in C. And with that, it uses JNI. And so in JNI, it's a Java native interface, which allows you to interact with it. Now, so for instance, if you ever needed to access or take advantage of graphics cards, say you don't want to use a game, that you don't want to create graphics, you just want to use, say, a machine learning, a neural net, and you want to create weights, and you want to produce this computation in a matrix form. You can give it to the GPU and it can immediately calculate all these things concurrently very quickly, but off of the Java's memory heap, off of the Java's memory heap. You're accessing it via Java, but you're actually calling into Java or C. So just to give you more context as to the pain points of JNI, I always show two perspectives. And this is a real story because JNI has been around forever, and I used to write JNI code, and I used to, as an implementer of an API. So you would write the C code, you would write the wrapper code, and then you would create an API that's friendly to Java developers, and then Java developers would use that API. And that's the implementer of the API's perspective. And then there's the user of the API. So you're the consumer of this library, and you don't really know how it works. It's just magical, and all you know is Java. So your intent is to use this thing that is high performance and does all this really magical stuff, but you have no idea, like, it's written in C and natively. So from an implementer's perspective, just a quick primer, or some people call it primer, the idea of how to implement JNI. So this is very painful. So the first thing you do is you create an interface. It's in Java. And in that interface, usually when people write Java code, you create interfaces before you create implementation code. You implement the interface, or if it's an abstract class, you extend from. But the keyword called native allows you to, that's a keyword, so it allows you to create the API for the Java developers. So the Java developers are going to call this function to perform some action. And it's no implementation. And so what you do is, from the Java command prompt, there's a tool called Java H. And it's -jni. And after you've compiled it, right, when you say Java H -jni, you're actually targeting a compiled class file of that interface. So, just like interface or class, when you compile it, the extension is .class, right? So you get bytecode, but that interface, once it's compiled, you use that Java H command and you point to the class files, the compiled Java class files. Now, the new thing in Java 10, I think it's after they added some feature that you can look at source code. So you're pointing to a Java file. You don't have to compile it because you might have problems compiling it. So they kind of made it a little bit easier for the implementer of the API. So afterwards, once you generate using the Java H, it'll generate these C-specific header files. So header files in the C native language world is very much like Java's interfaces. There's no implementation, they're just the method signatures. In the C world, it's called function signatures, right? So they have primitives very similar to Java, which we'll go into later, but the idea is that this is not implementation. So it'll do this name mangling, this weird underscore, camelback. Thank you. Just closing the door. So afterwards, once you've generated the header file, now you can start implementing the implementation code, which is actually C. So it's a C file. In the C world, you either have header files or you have C files. And the C source files are the implementation code that maps to the header files that is kind of like interfaces, right? So this is just a primer on how to develop implementation code connected to a interface, and you're creating a header so that you can use it to implement it. So afterwards, when you compile this, you will then get an artifact for that platform. So if you're on Windows, you'll get a DLL file. And there's a naming convention. So for instance, if you're on Linux, it'll say mylib.so. And in Macintosh, it's mydylib, or dyn-dylib, like dynamic loaded libraries. And so the naming convention is important because it's always, whether it's Mac or Linux or Windows, the main name is called mylib. So then, since Java 1.0, back in the day, when, like, say, for instance, JDBC drivers. There used to be the concept of type 1 or type 4 drivers. Type 1 drivers were really native, using C to talk to, like, Oracle or something. So you would load that library using system.load library, and it's just named like that. And of course, you would distribute, Java's supposed to be write once, run anywhere. But if you're delivering it, it's very specific to the operating system. You have to deliver that DLL. So for Minecraft, if you're running it on a Linux machine or you're running it on a Windows machine, they run the same. They're using the same DLL. Well, they're not using the same DLL, but when you compile it, you get a DLL for the Windows platform, and you get a DLL or an SO file for the Linux, and then you have a dylib for the Mac OS. So from perspective of the user of the API, you have no idea about how to implement. You don't have to create Java H, and you don't have to generate any of this stuff. another true story. Back in the day, I used to work on a project, and this project was a pure Java project. But I had to access Outlook. We had to schedule appointments or events, or we had to create tasks, and it had to do reminders and all this stuff. But how do you pass it in? So back in the day, it was just purely DLLs. I mean, you're not going to get some web service or REST endpoint to kind of populate the data and just be agnostic. You had to use, before then, they didn't even have C#. And now you had to write C#, and you're in a CLR, you're not in a JVM, so it's really complicated. But anyway, so back in the day, my team said, hey, we're going to go and look for a JNI project, and look at the date there. It's pretty old. But anyway, he still maintains, it's Dan Adler. It's called the Jconf project, and it's called a Java COM bridge, basically. In Microsoft world, they have what is called COM, or ActiveX controls. And it's native code on the Windows operating system that talks to native libraries on the platform. So you can do a lot of Windows-specific code. So at some point, if you want to write against some resource on that platform, you need to talk to it natively. So here's a typical way you would develop against an API that is already written. You have the DLL available. Of course, this only works on Windows because Outlook, does not work on Linux. So there's no SO file. But anyway, when you use this library, it's really nice where you write your business logic. That's your application. You're trying to talk to those interfaces, where you see the native keyword and you've compiled this thing and it talks to the native library, the DLL with the system.load library. It's literally talking to this thing loaded in memory, and it's looking at this binary, and it's actually trying to access the native code. So the Java H actually generates the mappings so that it's transparent to the library. It thinks it's being called from another C function, but it's really Java. So then ultimately that wrapper library, the Jconf.dll, is literally talking to the native library on the platform. So wouldn't it be great if you could just talk from your logic directly to the library, bypassing the wrapper code, the actual implementation code, and that native library in pure Java, just pure Java code. So that's where we can now have Project Panama. So Project Panama is actually more than that. So that's an Office Space, or that movie reference. Do you remember he burned down the building? Yeah. So what is actually Project Panama? Project Panama is not just a simple calling into a function, which is what this talk is mainly about, just to get you introduced. It's called Foreign Function Access. But it's really an umbrella project consisting of more than that. From left to right, there's something called the Vector API, not to be confused with Java util vector. If you know about Java collections is about lists and maps and such, and this is not that. Vectors is about vector chips or SIMD hardware, where you can do computations very efficiently, where your bytes are laid out, and it can do them simultaneously without having to, it's actual hardware on your the newer computers. So you can actually do a lot of floating point math very, very efficiently. But just being able to access that through Java, it's just a no-brainer. It's like you're taking a huge workload, it's some huge matrix math or something, and you're passing it to the Vector API, and it does like this huge matrix addition, and then it gives you the results. So it's kind of like doing it outside the JVM and doing the work just like JNI. You're talking to the hardware, and then it comes back. Now, moving from here, this culmination, everything on the right, is what this talk is going to be about. When they first started about native access, they were thinking in terms of like how you would access foreign functions like C. And the problem was they really had, the main problem was memory. So the foundational libraries had to do with memory. So memory was a big deal because there's different memory architectures, which we'll go into in a second. So here's just a quick timeline. This is a huge effort. It's happened, I don't know, at least 7 years ago. So there's a lot of PhDs that are always thinking about new ideas for the OpenJDK, and so many of these JEPs or AKA Java enhancement proposals were actually created during these times. So Java 2018 to 2021, and then earlier this year, you have this JEP, which is this talk. It's the newer, it's the preview release, which is now released in Java 19. That is, I don't know, I think it was last week. So Java 19 went into GA, or general availability, and you can access it. It's in, because prior JEP, or JEP, it's right there, 2021, it says JEP 4.12 and 4.19. They were in incubator modules. So in Java 9 and up, they created modules. So if they're newer things, like newer projects, they'll put them in incubator, like incubator 1, incubator 2, but you'd have to include them. You couldn't just, you know how some things come easily in Java. It's like java.lang. Or java.math, you know. Now with it in preview, it's in Java proper. I show you right there. So that used to be the incubator module, and then with the Java preview edition, it's now proper. It's like java.lang.foreign, and you can import it and start using it. And of course, on the command line, which we'll talk about later, is, you know, the get Java command, because it's preview. I don't think they're going to have a preview 2. They could. They've done it in the past. If I believe the APIs are pretty solid, but they might. So this is not an LTS release. This is Java 19 is not an LTS release. Java 17 is. So why? Well, can you guys see that okay, or is that kind of? Oh, that's kind of strange. So anyhow, here are the main benefits of Project Panama. Like we said before in that diagram of the user of the API, as that perspective goes, it's ease of use. You're going directly from, you know, your Java code, you know, into the native library using Panama or the foreign function APIs. And of course, because it's you eliminate those layers of indirection, it's as fast or faster than JNI because you don't have to go through those layers. And of course, the foundational APIs, the memory access APIs, those are those other JEPs that you saw on the bottom right. They can target different memory architectures, and we'll kind of talk about that. So safety, you have to, it's disabled by default. There is a switch on the command line that enables native access, which we'll show you in a simple hello world. So how does it actually access these native libraries? Currently, Project Panama only supports the native language C. because of the CABI, which is a well-known, that's weird. There was a well-known convention because, C's been around forever. It's called the Application Binary Interface. It allows, even Python has been doing this for a while too, with notably like TensorFlow. TensorFlow is written actually in C. So Python, all the tutorials and examples are written in Python. However, Python is actually using their ability to talk to native code also. So now that Java can do it, the native library has no idea that it's being called from something. It could be Java, OpenJDK, it could be Python. So the idea of following this convention that's been around forever, and it's really easy because C is not that hard. There's no multiple inheritance, there's no method overloading. It's pretty succinct, and except for pointers, but. So that's what I was going to say. And then also, we talked about calling into functions. Now there's a concept of callbacks. Like if something does something very quickly, like say in a game, you're actually doing some computation, you want to notify the Java application. So the callbacks are kind of fun. They're easy to use. So you're actually creating Java code, and you're allowing the C function invoke your Java function or Java method, whichever way. They're kind of synonymous. So here's an example of me using the foreign function API. I'm using the SDL library, or Simple Direct Media Layer. It's where a lot of media companies, they'll use to create, or game companies, they'll create it, or like production software and such. You can have inputs, like sound inputs and things like that. And then, of course, OpenGL allows you to, do graphics and pixel shaders and such. If anyone's familiar with OpenGL, that's how that lightweight gaming library, that's what it actually is accessing, is OpenGL underneath the covers also. So that's a really quick example. This is pure Java, talking using foreign function APIs. I'm actually using another tool called Jextract, which I don't go over in this talk. I used to, but in the links later, I'll show you that I have all these tutorials, so most of the details are all laid out in the, this is just an intro. So just to give you what Jextract actually did for you, instead of using the foreign function APIs, where you would have to create bindings, and that's what I'll go over. But the idea is that Jextract can do all that naming for you, and it generates the code for you. So it can generate the source code for you. It's really impressive. So for instance, if you look at actual C code or C++ code, when you're writing, say, the face of a cube, and you're building the array of points within the face of the cube, you're creating polygons, and you're doing the rotation. That C code looks just like that, but this is in Java. So Jextract actually generated the GL color 3, FV, or GL vertex 3 FV. So it's really cool that you could just use these functions. They're Java functions, and they look just like the C code when you were, if you were used to in college. I don't know, sometimes some colleges teach OpenGL, but the idea is to translate your code into the Java world. And so this is Java code. This is simple Java code. So I created a method called cube edge, and I take the array, and I'm just assembling, I'm just calling into these functions, just assembling the cube, and this code looks just like the C code. The only thing difference is in C they have these things called defines or if defines, and you can actually, they're basically public final static variables, and it looks just like it, except in JExtract it turns it into like GL underscore no error. Instead of just a single constant, it has parentheses. It's literally calling a little function that will return that value, because that value could be anything. Because in C you can change byte orders and you can deal with very low level aspects of memory. So just calling it, so JExtract actually generates all the Panama, like the low level Panama code, which we're going to do a hello world example. But this is just nice to know that if you ever had some old code that you were playing with 3D and OpenGL, you could just simply literally copy it and just change a few things. Of course, you'd have to run JExtract against the libraries, the header files that exist when you're in that development kit. So here's the last example of how to render. This is not important. This is just to demonstrate the way it looks in Java code, very similar to in OpenGL. So if you're looking at a tutorial in C, you would probably see that. So here's a video of me doing a talk, and that video is like an MPEG-4 file. So just think of a video. But anyway, what this is, I created an app. It's called World Clock, and this is pure Java. It's using Java FX. Now the video itself of me, I'm sorry. Oh, yes. This is a pure Java application. And what I do is I create an overlay over the video. So these libraries, that native library called FFmpeg, can take a stream of a video. So the video is being streamed and it's put in the Java FX canvas. And then it puts an overlay over it. And I created a library that creates what is called callouts. And callouts, they do the little circle, little animation. It's kind of like cool, right? But the idea is that this is pure Java, and the native code that it's accessing is FFmpeg using Project Panama to access that library to stream the video, the MPEG-4, into the Canvas node within Java. So I can actually use the library when I need it, and I use Java FX. I create a glass pane, and so you can click on the surface of the video as it's being played, just to, so it's Java FX, and then you're talking to using Project Panama. Again, I'm using JExtract because a lot of the functions in native code, you kind of want them in the Java world, so you can call the Java functions just like in OpenGL. So how do you get started? It's really simple. 19 came out a few days ago or last week. It's Java 19. This goes to our site. You can download it. You can go to Oracle if you want, but you can get charged. Just kidding. But yeah, this is their community edition. You can get other distributions from other places if you want to get into it. So there's a community site called fuj.io/download, and there you can pick any distribution, Tamarin, whatever, all your distributions. So you can pick Java 19, and you'll have Preview Edition. It's in there. So this is actually the development branch. This was when it was EA, Early Access. Now that it's not, that's a mistake right there where it says Early Access. It now says GA. So You could also hit jdk.java.net/20 because 20 is in development mode. So if you go to here, you can get those downloads, but if you're getting EA, there are changes all the time. So you never know, but since it's GA, the APIs are the same. So it's really quick, just like anyone on the command line setting up Java. You download the JDK, you put it in some temporary directory, you set up your environment variables for Java home and your path. And of course, you say Java home /bin to prepended, and then you put the current path on the end. And in Windows, there's the setup for that. So once you get that, or you could use SDKman, which a lot of friends use, but it's super simple. If you haven't heard of JDKman, it'll show you, you could pick any distribution, and I just chose ours. I'm a little biased. So just to verify, say Java-version, and that might be a little off because I changed the slides a little bit too late after the GA. So let's start actually creating Project Panama. But before we do that, let's look at what native C Hello World looks like. Really simple. Those that haven't seen C. So they have a concept very similar to our imports in Java, where you import libraries. And in here, this is most common. There's a set of libraries that are on the platform. Like Linux, when you get Linux, there is standard I/O, or even Windows. There's standard I/O. It's called standard for a reason. That's the standard I/O for input/output. Like when we use system.out.println, it's the printf commands within C. So they have a main also, just like Java. It has a return type though. Ours is public static void main, and this one returns this. But it's a concept in the Linux world or Unix world, which we'll explain in a minute. And so from standard IO.h, there's the printf command, where you're just outputting a string. Now this string is different from a Java string. There's the concept of a C array, and anything is an array at the very beginning is a pointer. So it's a pointer to an array. So it's a pointer to a character array. That's very important. So it's not the same as a Java string, because a Java string is really an object, while it's immutable. So return type in the Linux world or Unix world, they have the concept of using pipes. You can pipe one application to another, and they usually have this convention where 0 means okay, and anything else is a status code or some sort of error. So now we're getting to the meat of the thing. We're going to talk about how to actually use Project Panama and how to do this. So there are basically 3 steps. This is how you fundamentally do it, and there's other ways to optimize, so I don't have to go into that, but the idea is that JExtract will actually make these, we'll learn about it. They're called method handles. If they're public, final, static, the JVM can actually optimize those calls. But I'm just demonstrating how to create a method handle, and when you create a method handle, it may not be as performant that you would have expected, because you're like, oh, I thought foreign function is like faster, if not, as fast as JNI. What's going on here? It's because, well, you could have made it final static, but here I'm just demonstrating how to create it, not to optimize it. So just keep that in mind if you're ever hand creating a method handle. If you make it statically available and final, the JVM can actually optimize and make it super fast, and it will beat JNI. So the first thing you do is you create what is called a memory session. A memory session is a scope. It used to be called that in the previous JEP. But what you do is you create this using the try resource block in Java since Java 7, and which means that that object implements the interface closable. And so I just want to check out something here. Okay, great. I didn't know what time it was. So I think we're almost at time. Okay, so here we have when you create a session scope, there's the memory session class, which allows you to open that scope. And then I had to go back to the method handle. So when you create a method handle, there's something called a linker, which we'll go into in a minute. And then that you create this method. There's a method called down call handle. And then once you get the method handle, you're actually invoking, of course you have to create a string, a C string, that pointer to a character array. And it's really easy. There's functions in the foreign function API that allow you to create C strings to be passed into the method handle. So again, with the memory session, there's the open confine. There's other overloaded methods that allow you to provide scope, like there's shared scope. And what's great about the try resource block, because it has the closable interface implemented, it knows how to release the memory. So this is really important because what's great about the memory access APIs in Project Panama means that you can actually create memory that's off of the Java's memory heap. This is really important because you don't have to incur any of these weird garbage collection issues. It's literally outside the JVM. So once it closes, it's able to be notified and clean up and reclaim that memory. And there's other ones. Notice you see methods called cleaner. So if there's some weird order and there's some specialized malloc, you can actually implement your own cleanup method for additional cleanup. So a method handle is since Java 7, I believe. I don't know. It's really old. It's been around forever. But this is my definition. The Java doc definition is pretty very technical, but in a from a newbie standpoint, it's really just an object. You're referencing the symbol in memory. So the C function in memory is simply in memory. You're just calling the CABI. You know this binary. You know how to invoke it. It's just a reference to it. That's what a method handle is. So just looking at the signature again, what we are targeting, what we are trying to invoke as a method handle. This is the actual C function, so we have to understand how to describe the method or the function signature or the symbol. So the symbol is really printf, but we first, when you get Java 19 or Project Panama, there are predefined or generated, they're not generated, they're predefined in the JDK or Java runtime. When you get that, you get these portable things called value layouts .of int. It's like an inner class, but they're all of type value layout. And a value layout is a way to represent the primitives in the native world. But it's kind of weird, right? Because what does it mean to represent something as a primitive thing in the native world? Every architecture has different endianness, right? There's a big endian or little endian. So for instance, there's the most significant bit in the least significant bits. In some architectures, they switch them, and how they load them is really important. So you in Java, you're just saying, oh, that's an int. It's 32 bits, and it just works, right? But in the actual hardware, it's represented. The bits are represented differently. So there's APIs here, but these are predefined for you when you get your JDK, and it does the bit alignment and such. So that's the return type that we want to represent, which is very similar. I know it says Java _int, but when you use JExtract, it will create a one that's suitable. It'll say C _int. It'll create a value layout that represents a thing that you're going to hold in the primitive part of the native world. So here are the other ones, some other common ones. If you have a Java _int, there's one for double, there's one for float. There might be one for double, because in the native world they have other bit widths, depending on the native app platform. I mean, it could be even a different memory layout. They all extend from memory layout, but the idea is that you want to represent something on that platform. So for instance, if that platform is 16 bits, you might get this thing that you're not going to use Java _int. So when you get that, I don't think there's a Java, I think there's a Java 19 for Raspberry Pi, but I have to check. But the idea would be not that is 16 bits, but I'm just saying whatever native device, the idea is Panama is to allow you to talk to things natively, right? So that native device could be an int may be 16 bits. It may not be 32 bits. So the next thing to know about the function signature is the actual symbol name. It's just a text or a string. It's called, PRI, printf. So the first argument of a printf function is that pointer that I said, and that value layout that is predefined in Java 19 is called address. So if you're ever describing that function, that native function, and it says, oh, it needs a pointer, you're just going to put address there. This extends from value layout. And for that platform, it's probably 64 bits, the addressing scheme. So then this is var args, or they call it Verdict types, or you could specify anything. Like in Java, same thing with printf. Printf actually came from printf in C. So the idea of string interpolation, if you put %s, you could substitute it with strings. If it's %d, I think a double. So again, value layouts extend from memory layout. And then you have those inner classes that are predefined that map to the ones, actually those guys on the left. So OpenJDK, you get those predefined ones. If you use JExtract, you're going to get really close to whatever the platform is. So that, I don't know, I didn't have C Boolean, but a Boolean in Java is still 32 bits, right? So you could represent it with 1 bit, right? A 1 and a 0, but it depends on whatever that native platform is. So yeah, I just wanted to show you the native order and the bit alignment. So you won't need to be concerned with this, but in the Java doc, you can actually see all the ones that you can choose from. So if you know how to represent it, you see the function, and you can actually, the idea is to describe that method signature. That's the most important thing. So here are the native ones, and they almost map to the more portable ones that are predefined in Java 19. So now let's get on with this. That we're actually in the second step is to actually create the method handle. we first get a linker, and this is just a simple function from the foreign function API. You just get a linker. It's a concept within C. They have this concept of linkers. You're getting these symbols in memory, and you're just being able to access them. And being able to access them, there's a default lookup area. And the standard IO.h, all those standard things that you get to the platform, that's where you look up those symbols. So I created a little method chaining with they have a Fluent API, and it returns an optional of that value. So if it's null, it'll go to this thing. So I use an OR from the Fluent API. And there's another lookup area, and that is called symbol.lookup, loader.lookup, and you pass in a symbol. And I just did this a little kind of conveniency because you could create a function, and this is kind of convenient because if you can't find it, it'll throw a runtime exception saying, hey, this symbol doesn't exist. But that lookup area in the symbol loader lookup is when, in the very beginning in JNI, even in Project Panama, is the system.library or system.load library function that loads that native DLL or that SO file or that Mac OS library. So the idea is that you're trying to look for that symbol, but if it's a third-party library, you're probably using that system.load lookup, right? So that's the area where you look it up. But if you don't find it in either places, then it'll throw the runtime exception. Again, that's what I meant, if that makes any sense. Okay, so from the linker, there's a method called downCallHandle. So we know what the symbol is. We pass that in as the first argument. The second thing is called a function descriptor. And because we remember the predefined value layouts, we said Java underscore int or Java underscore float or whatever, we're really describing what printf is. So the first argument of the of method is describing the return type. So in a printf, it returns an int, a C int, and the first argument is what? A C pointer to an array of characters. And we said that we would use the value layout of address. And that's how you describe a printf. Now the veridict part, or the variable arguments, hasn't been described. So this is kind of painful because you're hand doing all this stuff, and JExtract can generate this stuff for you, and you could just use printf in Java just like it is in C. It's actually calling it. So we'll talk about that. So here's some overloaded methods. They're not really overloaded, but you get the idea. There's another additional method called of_void, which implies that the return type is void. So the first argument will be the first argument of the C function. So the idea is to, save a little bit of typing. You don't have to describe the return type, and it's kind of nice because a lot of functions return nothing. You're just calling it. So let's see. So we've got, really quick, there's a, memory session, there's a method called allocate UTF-8. It's a simple function from your memory session. It'll just create a C string, which is the pointer to the character array. So you're basically passing in a Java string, and it'll create this thing called a memory segment. It's really important. There is a proposal to combine, there's something called a memory address, which is an address or a pointer to the character array, but also memory segment is also the same thing as a pointer, but it has spatial bounds. So it's very, there was a discussion, and in Java 20 probably, they're probably going to collapse one of the classes, get rid of one of the classes and in favor of memory segment. So the concept of a pointer is something in the C world, but really it's just an address, whether it's pointing to null or it's pointing to something with spatial bounds like a struct or something. So once you've described it using the function descriptor, you have the method handle, you can start invoking it. So there's a function called invoke, and you actually pass in that string we created. And now it's actually calling it natively. There's another one called invoke exact, which is much more precise. It requires you to cast things. So like if it's returning an int, you better cast it to an int, or it'll throw an exception. So if you're lazy, you just call invoke, you kind of know the native function, you're trusting that it's going to do what, So again, we defined a function descriptor for just the first argument of the printf and the return type. Here at the end, it has this concept of multiple arguments because you want to do string interpolation and substitute values in. So how do you do it? So here's a quick example that this is what you want, where you take the two arguments on the right. So here is a string, and there is a simple int, and you want to substitute those values, and when it outputs to the console, boom, you get that sentence. If anybody knows that reference. Anybody know that reference?
Oh, yeah.
Okay, good. Exactly. So again, there's other convenience methods when you do a function descriptor .of. You can call, you can simply, the .of, the first argument is the return type. So you say Java _int, the value layout for that is that cint because the printf returns something. It actually returns the length of the string that you're actually outputting to the console. So kind of interesting. Like we don't think of that in Java. We just output something. We don't care about the number of characters. And so then there's the append argument layouts. So now this gives you an opportunity to start describing the things in this var args that you want to pass in. So you still have to describe them. So as a vardic, there's a function in Java in the foreign function API. It's called as vardic, and you're describing it. You're saying, I want the pointer to the character array, use the value layout address. Now the first argument of that string is universe, I believe, and that's a C string. What is that? A pointer to a C character array. It's an address. And then what's the last argument? 42, right? So that is a Java _int value layout. Now if you use JExtract, you can choose to use C _layout, which is generated by the generated code. But to be portable, you're probably going to be on maybe only 3 operating systems if you're doing something, more modern, I guess. And so here's how I showed you how to create or allocate a string. So you create the actual string, the C string, and it extends addressable. So it's really a pointer to something in memory. I believe that is also a memory segment, but the parent interface or class is addressable. That's not being collapsed. Memory address class will probably be collapsed in Java 20 because they're kind of like, there's different ways of thinking what a pointer is. In the Java world, you're always having a reference to something. So whether it's some value or a struct or an array or null, it's, So is there a better way? And I kind of explain that. And if you use JExtract, I don't explain JExtract in this brief tutorial, but it's really cool. You could point it to a header file. I point it to standard.io. You can only point it to one header file. So if you wanted multiple header files, like SDL library, OpenGL.h, and standard.io, you can put it in one file called foo.h, and you just include those three headers, and then you run JExtract against it, boom, it'll create all the functions for you. And you could change the name spacing and such. And so the name spacing, you say foo_h dot, and then you want to call the printf. You could change that whatever you want. But you're calling it just like it is in the native world, but it's in Java. So you created the C and it outputs it. So if you want JExtract, head over to jdk.java.net/JExtract. I don't think they support the M1 chip yet. So I heard they will. So again, the foundational libraries, when they came across, they said, oh, this is very fundamental. The memory access APIs, because of memory architectures. So really quick, I did talk about value layouts, but then value layouts extend from memory layouts. Memory layouts are, just the idea of how to, describe things in memory, basically. Like if there's a struct looks like a class, but the values, like in C, when you create a struct, say it's a person class or a person struct, that first name field, you're telling it to be 20 characters. It's not larger, or it's not dynamic like in Java. I mean, I guess you could put a pointer to it and it could have variable length, but that has to be well defined. So again, there's this thing in memory. Here is a C string. It's in this, the offset is at 0, and it's just a stream of C, and I believe it's null terminated. That's another thing about native world. And so here's another example. Say it reclaimed it and it's wiping it out, and then you're using value layouts. So you're writing along, and it's the decimal 10, and then to the right of it. And then you might still see text from the previous memory allocation. So this is important. This just shows you what it looks like in memory. So what do we do with C primitives? So what you do within, I showed you about these predefined guys, value layouts. You simply, I'm not sure what time it is. 3:20. When does the session end? 3:15. Oh my goodness. Yeah, I had a little late session. So yeah, in closing, let me finish. So from the memory session, there's an allocate method, and you take the value type, and you don't have to have that second argument, but it's a convenience. It'll put that math.py into that memory segment. So it'll create a memory off heap and store that value. And then you have to, then there's a getter method on the memory segment that allows you to get the value inside that memory location. And you could say 0, it's typically 0 offset, but then you can actually increment that, and it'll go to the next grouping of 64 bits and grab the next value. So you can iterate through using the offset. And so to get the value from the memory segment that we created before, and you want to convert it from a C string back to a Java string, there's that convenient method called getUTF-8 string. And then you're printing it now in the Java world, system.out.println. So This is how you set it. Again, you specify the value layout, and then the offset, and then the actual value that you want to set in native memory. So here's just a simple output. And so really quickly, I just want to go through these slides. You don't really have to, we're almost done, but JExtract makes all these things convenient for you, so you can just hit printf and even thefflush from standard.io.h. And of course, when you opt in, anything unsafe, you have to enable it. Enable native access equals all unnamed, and then you, in new Java 10, I believe, you can actually run a single source file of Java. Like if it's source code, like that says hello world.java, you just run it. But you would have, it's kind of like compiling it, so you have to specify the --source 19 if you're wanting to run source code. But if it's compiled, like hello world.class, you don't need that --source 19. You're just enabling preview, and you're just running a class file. So there's more that is not in this talk. There's pointers, there's structs, there's arrays, there's callbacks. There's even ways to talk to using the C ABI to foreign languages like C++, Swift, Python, and such. And and of course, over at fujay.io is where I blog a lot about Project Panama. That it's a lot of the examples of talking to Swift libraries, or talking to using. I have an example for Rust, which is really cool. So here's the source code over at GitHub. If you want to look at some of these examples from dealing with structs or array of structs and such. So if you guys want to get that real quick. Awesome. So in summary, those are the things that we talked about, Java and native access, and what it is, what's actually in the umbrella of Project Panama, and how does it actually interact with native code. And then I showed you demos, and of course, a way to hand code method handles using Project Panama. So here's some of the links. I'm sure these slides will be available for Jconf. So there you have it. Thank you. Appreciate it.